So the next thing that you want to do is create a constructor for your class. And what is a constructor? Remember when we created objects in Unit 1, we would have said something like this. I'm going to type this. You were not going to really type this here, but you would say something like rectangle R gets new rectangle, and then you would feed it all your values. Let's say you wanted 3, 4 with a width of 5 and a height of 6. This is the way that we want users to be able to create rectangle objects when we're done. Right? Not now. We're trying to design the rectangle class so this is the way that a user could create a rectangle object. Well, this right here is considered a constructor. The word new calls or executes a constructor. So we need to create those things right now. Okay, this is not real code. Let's comment that out so you don't get confused. But in order to create a constructor, what you do is you write the word public, and then you just simply retype the name of the class. The name of a constructor always has to be the same as the name of the class. So you just say rectangle and then parentheses. And the idea here is you want to have a variable now to represent different quantities that can be passed into a rectangle. So if we want 3 to be the x coordinate and the 4 to be the y coordinate of the upper left hand corner, and then 5 to be the width and 6 to be the height, then we need to create variables for those. So let's create a variable here called double x chord, double y chord, double width, double w for width. And the whole purpose of a constructor is simply to initialize the variables. The JVM will automatically find a memory address, a place in memory for the rectangle object, and will allocate enough memory for all the instance variables. So all that happens automatically. All we need to do is make sure that these variables are copied into the correct positions. So the very, very typical way of writing a constructor is to simply assign those values. So if I have x1 pos as an instance variable, it needs to receive its initial value, or in other words, we need to initialize it. So I've created this value here, x chord, as the parameter name, and so I want x1 pos to receive x chord. I want y1 pos to receive y chord. And notice the values on the left are the instance variables because they live in perpetuity with the object, right? This is our long-term planning. These are the values that represent the very essence of the object. These are temporary, we call them parameters. They're created only to hold the values that are passed in. So later when I write this line of code outside of this class, the 3 becomes x chord, and then x1 pos becomes that 3, which is x chord. So all those values get passed in appropriately. This is the essence of what a constructor would look like. Now usually you want to have multiple constructors. You can think of it as overloading the constructor method. You want to allow your users multiple ways of creating a rectangle. So for example, what if somebody wants to create a default rectangle? So if somebody's being really lazy or doesn't really care about the values of the rectangle right now and they just want to create a rectangle with nothing in parentheses, you kind of want to come up with default values for what a default rectangle would look like. So we can do that by creating a no-args constructor. So again, notice I've got the word public, I write out the name of the class, and then I've got open and close parentheses. This time I've got nothing inside because I'm trying to indicate that this is the constructor that will be used when people create a rectangle and place nothing in the parentheses. I could copy this pattern. In fact, let's do it right now because this is kind of the initial way you learn how to do this stuff. And we'll just say, all right, well, by default, they'll put the rectangle at 0, 0, and we'll give it a width of 1.0, 1.0. The point is that we give all the instance variables some default values. Now you can imagine, if I end up writing 10 constructors for a class, do you see how repetitive this is going to become? It's going to become really, really annoying. So luckily, Java has given us a very, very handy and very useful shortcut. You use the keyword this. So if you type the word this and then open and close parentheses, it means what you're doing is executing another constructor of this class. And what you do is you pass in the right permutation of parameter types so that Java can match this up with the correct constructor. So in this case, if I put in a double, then a double, then a double, then a double, Java is going to say, hey, I need to go find the constructor in this class that expects a double, then a double, then a double, then a double. So in this case, I want to type in 0.0 for the x coordinate, a 0.0 for the y coordinate, a 1.0 for the width, and a 1.0 for the height. And now, with just one line of code, I've executed the exact same thing that I had before. Java's going to say, all right, when somebody creates a rectangle and puts nothing in the parentheses, like I have here, I'm going to go in and execute this line, which goes into this class's constructor. Which one? The one that takes a double, then a double, then a double, then a double. It finds it here, and it passes 0.0 in for this, 0.0 in for this, 1.0 in for W, 1.0 in for H, and then assigns the instance variables just as we did before. And so it saves the programmer a lot of time, and it also allows us to update our constructors really, really nicely. So for example, if I add more code in here, I'm drawing a blank, so I'm going to do something stupid and just say system.out. I love writing constructors. Now, how many constructors did I just update right there? And the answer is 2 different constructors, right? Because when this constructor executes, it's going to execute this constructor, which is then going to have this line print out at the end. So the point is you can have one good constructor, you can put all your attention into one and make it really, really good and focus on it, and then have all of your other constructors just call that one. Let's say we want to have another constructor where people just want to say where the rectangle will start. So I want people to be able to create a rectangle and just to say where it's going to be. So I want this rectangle to be at 5, 6, so this time they're just going to put in 2 doubles. These are all int values, I'm realizing. Just so you know, it's always okay to use an int value in a double context because there's no ambiguity, right? Java can take a 3 and say, what is that as a double? It's clearly a 3.0, so I've been a little lazy here. But all right, so anyway, going back to what we're saying, we need to create our constructor that takes 2 parameters here. So we do the same thing, public rectangle, and I need to create a location for 2 different double values. And again, the quick way isn't to write 4 lines of code, it's to write 1 line of code. Makes sense? So again, if somebody were to create a rectangle like this using 2 values, here, I'll go ahead and make it clear and make it 5.0, 6.0. Java's going to say, all right, I go into the rectangle class and execute the constructor that anticipates a double and then a double. Okay, that's this one. So xpos receives a 5.0, ypos receives a 6.0, and then what do? Within the rectangle class, I go and execute the constructor that anticipates a double, a double, a double, and a double. So we go and we execute this constructor, and the xpos value, which was 5.0, is passed into xcord. The ypos value, that is a 6.0, is passed up to the ycord. 1.0 is passed up to W, 1.0 is passed up to H, and all the instance variables get initialized. And you can see that it becomes very, very easy to write lots and lots of constructors, which then allows users of your class to create rectangle objects in many, many different ways, which is really, really handy. Okay, there's one last thing about constructors that you really kind of want to pay attention to. I'm coming back up here and I'm realizing that I really don't like the names of my instance variables. If I'm going to use width and height, there's no reason to call this x1 and call this y1, right? I don't have a second one or a third one. In fact, I really like the name of my parameter here, xcord and ycord. Maybe I just want to leave that the way it is. So what I'm going to do is I'm going to copy that, I'm going to paste it on top of there, I'm going to copy that, I'm going to paste it on top of there, and now I'm looking at this and I'm saying, you know what, I really kind of like the symmetry of saying, hey, the name of my parameter is xcord and the name of my instance variable is xcord, but unfortunately you don't want to have 2 variables with the same name within the same scope. In fact, that's usually illegal. Except if one of those is your instance variable, you can have it because there's one way to differentiate it from other variables, and that is to use the keyword this in a second way. If I write this dot xcord, it always means the object's instance variable called xcord, and many programmers like to use this style. In other words, to have the parameters of the constructor use the exact same name as the instance variables they're going to initialize. Because as you can see, it creates kind of a beautiful symmetry. If I continue this, let's change W to width, and we'll change this to height, this dot width, and you'll see that there's a nice symmetry here. The instance variable xcord receives the value of the parameter xcord. the instance variable y chord receives the parameter value y chord. The rule that you want to remember for this is that anytime you use this dot, you are speaking from the context of the whole object or the whole class. The class's variable is always an instance variable. So this dot, any variable, is always an instance variable. And then the idea here is if you don't have this dot, Java is always going to look for the most locally defined version of that variable. And this variable, which is a parameter, is more locally defined than the instance variable. And so this just works fine, and a lot of programmers like this style. We are not going to force you to use this style, but we are going to force you to recognize this style. So there will be test questions where, you know, this will be in a question, or I might say convert from one style to another. So you have to be familiar with both styles. And again, just as a reminder, the other style is that if these are different variables altogether, you don't have to have this dot. So for example, there's no ambiguity here, right? There's no ambiguity here. If I say X chord, there's only one X chord that could possibly be, right? There's no ambiguity whatsoever. And if I say X, there's only one X that could possibly be. There's no ambiguity whatsoever. So a lot of programmers like this style as well because of the utter lack of ambiguity, which is also a good thing. Okay, that's a pretty good start. So we've talked about instance variables, abstraction. We talked more about encapsulation. The idea is we're making these private. That's encapsulation. We talked about constructors. We talked about a few different ways of making constructors. We talked about how you can use this dot, and we talked about how you can use this for one constructor to call another constructor. So make sure you understand all that, and we'll talk more tomorrow.